Question number 5. If E1, E are the eccentricities of the hyperbola and its conjugate hyperbola, prove that it means these are the eccentricities of hyperbola and conjugate hyperbola. Okay, prove that 1 by E square plus 1 by E1 square is equals to 1. Okay, equation of hyperbola is nothing but x square by a square minus y square by b square is equals to 1. We have to find the eccentricity of this. Okay, we know that b square is equal to a square into e square minus 1. Okay, from this we can get e value. Transfer this, b square by e square is equal to e square minus 1. Okay, from this e square will be take minus 1 here, it will become plus 1. E square is equals to b square by e square plus 1. Now take LCM, a square b square plus a square means a square. Okay, we got e square value. Okay, but we want 1 by e square. See, we want 1 by e square. 1 by e square is nothing but reciprocal. Okay, see, if you write 1 by e square value, so it will reciprocal as it is a fraction in the denominator, so it will become a square by a square plus b square. Okay, so 1 by e square is reciprocal of this a square by a square plus b square. First equation. Similarly, we will find for conjugate. Okay, equation of conjugate hyperbola is y square by b square minus x square by e square is equals to 1. That is nothing but x square by a square minus y square by b square is equals to minus 1 is the conjugate, but we are writing in this form because we want only plus here. Okay, to get positive 1 here, we have to change the signs of this. This will become positive and this will become negative. So y square by b square minus x square by a square is equals to 1. We know the formula a square is equals to b square into e1 square minus 1. We are writing e as e1 here. Okay, for conjugate. Now we want this value from this. So b square will go in the denominator. A square by b square is equals to e1 square minus 1. Take this 1 here. It will become plus 1. Now take LCM. B square, a square plus b square is equals to e1 square. We got e1 square value. Now we want 1 by e1. That is nothing but reciprocal of this. A square plus b square by b square will become b square by a square plus b square. Okay, we got 1 by e1 square value. Now we have to add these two to get this value. 1 by e square plus 1 by e1 square, okay, is equals to 1 by e square value is a square by e square plus b square plus this value. Okay, denominators are same, so after taking LCM this will be same. A square plus b square will be the LCM. Okay, as this is like fraction, it means both the denominators are same, so numerator will be same. A square plus b square same. Now cancel, you will get 1 because both are same. So 1 by e square plus 1 by e1 square is equals to 1. Hence proved. Question number 6. Prove that the point of intersection of two perpendicular tangents to the hyperbola x square by a square minus y square by b square is equals to 1 lies on the circle x square plus y square is equals to a square minus b square. Let the point P x1, y1 be the point of intersection of two perpendicular tangents to the hyperbola. Prove that the point of intersection of two perpendicular tangents. So we are considering one point of intersection, that is P of x1, y1 of point of intersection of two perpendicular tangents to the hyperbola this. Okay. Now equation of the tangent can be taken as, we know the equation of tangent of hyperbola is nothing but y is equals to mx plus or minus under root a square m square minus b square. Okay, since this is passing through this point, so substitute x1 y1 at the place of x and y. y1 mx1 plus or minus under root same. Okay, now take mx1 here. y1 minus mx1 is equals to under root a square m square minus b square. To remove this root, squaring on both sides. Okay, now this square and root gets cancelled. Now it is in the form of a minus b whole square. So a square plus b square m square x1 square minus 2 a is y and b is mx1. Okay, is equals to a square m square minus b square. Now taking these all terms left side, y1 square m square x1 square minus 2mx1y minus a square m square and minus b square is equals to 0. Taking all this term to the left side. Okay, now m square and this is also m square, taking common m square from this, so you will get x1 square minus a square m square. Now m term minus 2m x1y plus now constant term which has no m term, y1 square plus b square. Okay, x1 square minus a square m square minus 2x1y m, then constant number. It means this is m square, this is m, and this is constant with no m value. Okay, this is a quadratic equation in terms of m, giving the value set m1 m2, which are the slopes of the tangents passing through the point P. Okay, m1 m2 are nothing but slopes, and the are roots also, roots of this quadratic equation. Okay, so since the tangents are perpendicular, we know the perpendicular condition is one slope is equal to minus 1 by other slope. Okay, m1 is equals to minus 1 by m2, first tangent and second tangent. Okay, so now multiply here, m1 m2 is equals to minus 1. So this is nothing but product of two roots. These are roots also. Okay, so product of roots are nothing but alpha into beta is equals to c by a. C and a are nothing but the coefficient of m square is a, coefficient of m is b, and this is c. A x square plus bx plus c. Okay, so a is x1 square minus a square, b is minus 2x1y, and c is y1 square plus b square. Okay, now substitute this in this. m1 by m2 is nothing but c by a, which is equals to minus 1. Okay, c value is y1 square plus b square upon x1 square minus a square, which is nothing but a, is equals to 1. Minus 1. Cross multiply. This one same as it is, minus 1. x1 square minus a square. Multiply minus 1 here. It will become minus x1 square, minus into minus plus a square. Okay, y1 square plus b square is equals to minus x1 square plus a square. Okay, now take this here. It will become y1 square plus x1 square is equals to a square, and take minus b square here, it will become minus b square. Okay, so this is the required proof to prove this. Okay, therefore the locus of the P is x square plus y square, that is x square plus y square is equals to a square minus b square, hence proved. Question number 7. Tangents to the hyperbola x square by a square minus y square by b square is equals to 1 makes angles theta 1, theta 2 with transverse axis of hyperbola show that the point of intersection of these tangents lie on the curve this when tan theta 1 plus tan theta 2 is equals to k. This question is similar to the previous one. Okay, here it has given that point of intersection to these tangents. Two tangents are there, so we have to consider one point first, that is P of x1 comma y1. See here. Okay, see first, give equation of hyperbola is x square by a square minus y square by b square is equals to 1. Equation of the tangent to the parabola can be written as y is equals to mx plus or minus under root a square m square minus b square. Okay, since this is passing through the x1 comma y1 with the point of intersection to the tangents. Okay, so we have to substitute x1 y1 at the place of x and y. It will be y1 is equals to mx1 plus or minus under root a square m square minus b square. Okay, now take mx1 here. It will become y1 minus mx1 is equals to plus or minus under root a square m square minus b square. To remove this root, squaring on both sides, y1 minus mx1 whole square is equals to under root a square m square minus b square whole square. Square and root gets cancelled. Now it is in the form of a minus b whole square, a square plus b square minus 2ab, y1 square plus m square x1 square minus 2ab, okay, is equals to this one same as it is. Now take these terms here. It will become minus a square m square, and this will become plus b square. Okay, now taking common m square from these two terms, so you will get x1 square minus a square. Now m term minus 2x1 y1 m plus constant term which has no m term, okay, is equals to 0, which is a quadratic equation in terms of m, and m1 m2 be the roots of the equation. Sum of roots is equals to minus b by m. We know for the quadratic equation ax square plus bx plus c is equals to 0, the roots are alpha and beta. Alpha plus beta is nothing but minus b by a. Okay, a and b are nothing but the coefficient of this. See, for x squared, the coefficient is a. For x, the coefficient of b. So similarly, for m squared, the coefficient is a here, and coefficient of m is b, and this constant term is c. Okay, so a is equals to x1 square minus a square, b is equals to minus 2x1 by 1, and c is equals to y1 square plus b square. We have to substitute here. m1 plus m2 is equals to minus b by a. Okay, why we are taking m1 plus m2? Because in the question it has given tan theta 1 plus theta 2, because m1 and m2 is nothing but tan theta 1, tan theta 2. M is slope, slope is nothing but tan theta. In the previous question, we have taken m1 into m2 is equals to minus 1, because there we have applied perpendicular condition. Here we want tan theta 1 plus tan theta 2. So we are sum of x is minus b by a. Now substitute b and a value, and m plus m2 is nothing but tan theta 1 plus tan theta 2. See, m1 plus m2 is equals to minus b value is this much, minus 2x1 y1 by a. Okay, minus into minus plus 2x1 y1 by, same as it is, m1 is tan theta 1, m2 is tan theta 2, slope. Okay, given in the question tan theta 1 plus tan theta 2 is nothing but k. So substitute k is equal to this one, same as it is. Now cross multiply, k into x1 square minus a square is equal to 2x1 by 1, hence proved. Therefore the p lies on the curve 2xy is equals to k into x square minus a square, hence proved.